Hello guys, Harsh Verma here, welcoming you second time in this video because this video is going to be about CDN, the complete content delivery network, and I have already shot this video uh, 1 day ago, but actually due to some technical issues, or you can say due to some power cutoff issues, the video was not able to be saved on my device. I have spoken for more than 1 hour on that video, and nothing, just 3 seconds of the clip of that video only got saved because of the power cut that got in between, and I have to switch off my computer in between the video. But never mind, that effort that I've already pushed is not gone in vain, as I have some complete or some total understanding of the topic about CDN. So we will finish this CDN as smoothly, as quickly as possible in this video or in this stream. So without any further delay, let's begin with our Firefox instance as well as VS Code instance. Let me close these tabs first. Okay, opening the current tab, which was development Cloudflare Hirsch. And I'm very sorry, guys, that I haven't put the link of all these things uh, into the video description of any of my videos, and neither I have actually hit it. As you can see, I have already mentioned the topic CDN here because, as I just told you, let's navigate to Cloudflare first. Learning Center Home, and we will learn about CDN in this video. So mishappenings happen, but that doesn't mean that I will stop making these kind of content. Let me go to dark mode first. Yes. So what is the content delivery network? Is a delivery network is a geographically distributed group of server. Okay, that caches content close to end user. A CDN allows for quick transfer of asset, for such as internet content, HTML pages, JavaScript files, a style sheet image, and videos. So, as this website is developed, it is developed using various things. For example, this is the HTML of the website. It may be possible that this website contains image, video files, etc., that are also being originated, or the also being served from the main origin server. So in order to reduce the load of that server, a geographically distributed group of servers are assigned to share the same thing, but in the closer side. Okay, so this works like, for example, if I open a blank sheet of web page, uh, let me enhance the thickness. Oh, so there here is our client. The client is in India, IN, and this Cloudflare website is actually a US based company, I guess. If this is a US based firm, this is Cloudflare. Okay, and this is US. If I request something, or if I visit this CDN, if I visit this article on the CDN, what this CDN server actually do, that is there is some location in Delhi, or maybe in India as well, hosting the same content, hosting the same files that Cloudflare website needs. And if I want this file to be addressed, actually my address is fulfilled by this server, and this server is called CDN, Content Delivery Network. Okay, next. The popularity of CDN server continues to grow, and today majority of web traffic is served through CDN. So this article actually talks about how this CDN server actually got its traffic. Suppose this is in the pathway. If I have to, we have already learned that how the hop matters in terms of connection in the internet. So this is in between the path of the India and US, this server and this client. So if some query is passed to this, it first checks its own server, just like the DNS server we have learned earlier. If it has its content cached and the same content is requested by this client, then it will send its own content. But if something is not cached, then the CF will ask this main, then the CDN server will ask the main server, and then it cache it first, and then after that it will transfer that content to India. For the first time it will be delayed, but after that, every time whenever the CDN is queried, it offer the faster response. Okay, a properly configured CDN may also help to protect website against some malicious attacks, such as distributed denial of service attack. We know that this is the frontline army that protects the main server. So even if the attacker, suppose multiple clients, this time I am donating with B1, B2, these are some bots. If they try to attack this main server, but they first have to go through this what to say CDN server, and CDN server usually is much powerful than the main server and is able to tolerate or handle multiple loads, serving the legit user as well as malicious user. Okay, so the benefits of using a CDN is improving website load time, because the only slowdown is at the first when the server don't have its cached consent. But once the server caches the original content, the website load time improves drastically. Next is reducing bandwidth cost. So bandwidth cost is actually not the bandwidth cost. It is represented as bandwidth cost because bandwidth is the total capacity. Suppose I am connecting with Wi-Fi, and the Wi-Fi says that its link speed is 4 Mbps. Mbps. So it doesn't mean that my Wi-Fi actually runs with 4 Mbps in it. Bandwidth is the total capacity. The actual thing that we are talking about in the name of bandwidth cost is actually the throughput of data. Throughput is for example, my link speed says that I will work at 4 megabits per second. Okay, but my internet provider provides me an internet connection of 1 or 2 megabits per second. So I am being charged using this data, not by this. This is bandwidth and this is throughput. I know this is slightly misleading, but yeah, this web article also says that a bandwidth consumption cost for the website hosting is primary expense for website. And actually, not particularly this one, but there is a separate article regarding the bandwidth cost, which we will see. I know because I've already seen that. Okay. Finally, third is increasing content availability and redundancy. Large amount of traffic or hardware failures can interrupt normal website functioning. Thanks to their distributed nature, a CDN can handle more traffic. I have already told you. And finally, the website security, because it helps to mitigate the DDoS attack. Okay, how does a CDN work? This article or this section is most important in the whole page. At its core, CDN is the network of server linked with the goal of delivering content as quickly, cheaply, reliably, securely as possible. To improve speed and connectivity, a CDN will place server at exchange point between different network. What is the internet exchange point? These are the primary location where the internet provider, not us, but the internet provider, connect in order to provide each other access to traffic originating to their network. Uh, by having an internet connection or by having a connection to these high speed and highly internet connected location, a CDN is able to reduce cost and transit time in high speed data delivery. So in this diagram, we can see, first we let me enable my annotation. Yes. So in this content, in this article or diagram, I can see that this is the origin server where supposedly this cloudflare.com/learning/cdn/what is cdn.html is hosted there. but it is cached in multiple locations. For example, this is a CDN server, this is also a CDN server, this is also a CDN server, this is also a CDN server, and this as well. So, for example, there are almost 1, 2, 3, 4, and 5 CDN servers are currently. So even if this client one asks for the same website, suppose I am in India and I am also as a client two asking for the website. Ideally, my website should be hosted here, so my request should be gone to this. But actually, it is being served by this CDN number 3. Okay, and DDoS attack also works the same way, because this is geographically distributed. I'm very sure that there must be another CDN server for the here as well. So if some DDoS attack, multiple bots starts querying the same web page or same website. Few of them are served using this, and when this CDN, particular this CDN C2 starts failing load, then these are being served by this or this, and this is how the CDN helps to distribute the DDoS intensity of the traffic and helps to prevent the DDoS attack. And let me clear it all. Yes, and finally we will learn about latency. What is latency? uh, but what is latency? Actually, there's no mention of latency, so we will copy it and open a new article. Latency meaning, let me zoom it so you guys can see. Latency is the state or quality of being latent period, or basically delay. The time taken between if you ask for something and actually that thing occurs is the between is the drop off time. And when it comes to the website loading content, user drop off quickly as the site slows down. CDN service can help to improve the load time, because it is globally distributed. Hardware and software optimization such as efficient load balancing, SSD, and which helps to reach the data and user faster. Suppose, let me give you a solid example. For example, as this is a computer, this is a smartphone. So for those are not, this is a smartphone. uh, a smartphone or computers do pose ability to host content on itself. It is not smart to do so, but they have the ability to host a website. For example, this is computer. This is a very old computer with a 5400 RPM, I think rotation per minute, drive, hard disk drive in it. Okay, and there I stored a very large video file. Okay, and actually the hard drive itself is not much capable in order to store and run some very demanding things. For example, if multiple devices, suppose this laptop is actually serving the content on the internet. Okay, this is client 1, C1, C2, C3, and if they are demanding for the same video, then this laptop have to originate several streams of the data of the same thing to each and every one, and this laptop is itself not capable of doing that. But for a simple example, if this laptop ables to do that, then this hard drives, this slow state hard drive starts to failing because this is not capable enough to run and you generate enough for the every client. So that's why the CDN, if I use a CDN in between, suppose in between let's introduce a CDN uses the SSD. This first copied the data from the here, and then every client is served with this CDN, and now the every client will experience a much better service by using a CDN service rather than depending on the origin itself. Don't save. Yes. Next is CDN can also speed up site which use the TLS or SSL certificate by optimizing connection and reusing or enabling TLS false start. We have to study the TLS false start, and it is, I think, stored in glossary. So we will see that. Finally, the CDN will also keeps an website always online. For example, a CDN do go by some, one second, let me open it. CDN do go by something called TTL. We already know that it stands for time to live. Okay, so CDN store content for some specific period. For example, this is my origin server. Where is my pen? And this time let me try another different color pen. For example, purple. Okay, so CDN actually stores, CDN go by TTL. So this is my origin server. Origin server stands for OS. Okay, and this is my CDN server. CDN server goes by CDN. Suppose I have to do some fixes here. Okay, I want to make it a spanner, but never mind. Okay, so I have to do some fixes here, and this fix will take 30 minutes to complete, or 30 minutes I have to update the content. So what I can do, by sharing the time to live to almost around 30 minutes time period, I can cache all the content of this origin server to a CDN. Then all the traffic C1, C2, C3 will be served using this CDN, not by this origin server. Hence, it can be offline for a 30 minute for a regular maintenance service. And this is how a CDN will keep the content always online. CDN also provides some failover services. Failover services means CDN servers can go offline due to hardware malfunction. So CDN in itself maybe depend on multiple servers. So along with this, the CDN CDN itself, if need something called servicing, then CDN will automatically offload this content to other servers as well. So the users can be keep continuing served, not by this origin server, not even by this CDN, this particular CDN, but by another servers presented in this CDN group of network, because CDN is separate, geographically separated group of servers. Hence, it is not a single server, and it provides the failover possibilities. And next, in the event that an entire data center is having technical issues, Anycast routing transfer the traffic to another available data center, ensuring that no users lose access. This is the same as the example we have just seen uh, when we are discussing the DDoS attack in the diagram presented above. Here I have discussed, suppose there are multiple users arise for the same CDN, thus any cast network that used by CDN will automatically shifts the traffic to another CDN, because it is experiencing the high volume of users. So it will automatically transfer some traffic to here. That's why it reduces the problems. And finally, the information security is an integral part of CDN. A CDN can keep a site secure with Press TLS SSL certificate, which will ensure a high standard of authentication, encryption, and integrity. Investigate the security concerns surrounding CDN and explore what can be done to security deliver content. Okay. And finally, the cost reduction, bandwidth cost. Actually, using a CDN service is sometimes costly, but the cost, what to say, the cost of using CDN is outdone or overthrown by the actual bandwidth cost that an origin server provider will charge you. Hence, using a CDN server is much more smarter, and using a CDN server is much far more cheaper than paying the origin server bandwidth cost. And I have already told you that bandwidth cost is actually the throughput cost, actually the utilization that you done to that bandwidth. Okay, and then we will discuss the same thing for the 4 articles, and then we will start dealing with new things. So these are just the same thing. So I will just overview it as a group of server. Okay, 4 benefits: better performance, we have already seen; increased reliability, we have seen; the cost saving, we have seen about that; and resilience against cyber attack. Specifically this time in this article I am targeting the cost saving, because we have seen that the performance, how the performance is improved. Let's see at least factors how the performance is, because we have decreased the distance between content is stored and where it's need to go. We can reduce the file size, and we how can we reduce the file size? We can use the code minification. With code minification means changing the variable names if it is a code, and compressing the file if it is a video or audio or something else type kind of file. So the file can be compressed as well. And finally, optimizing the server infrastructure. We have just seen the example with SSD and HDD, because the CDNs have a faster kind of networking devices as well as storage device. Hence, these response to user far more quicker than the origin server. We have already seen the reliability, and we are very familiar with how the load balancing work from the previous video. You can go watch that. Next, specifically, I'm talking about cost savings. The main way CDN cut down cost on expenditure by reducing trip to and from origin server. I have to make a very clear example or very plain example. Okay, this time I'm going with red for this one. Suppose this is our origin server. Origin server starts with O and S, origin server. And this is the CDN server. Okay, CDN. Okay, and this is our client. Client should not be a server, but never mind, client. Okay, so the we have set some basic charge. Okay, for every query that origin server receives will be charged as $1, and this is will be the receiving charge. And for every query it send, it will be charged as $2. Okay, this is the charges for the origin server. But for every query it receives and sent, the CDN is being charged as what to say 1 cent, 0.1 dollar. Okay, and for every query it sends, it will be charged as 0.2 dollar. Okay, but the CDN server come with a catch that you have to actually provide it a $2 or $5 as the one time fees in order to enable this service of CDN. So you will think that the CDN service is so costly that it costs the $5 upfront. But when one user actually visits, when one client actually visits the website, uh, for example, this want to visit a website hosted on this. Okay, so the request goes from the CDN. So CDN will receive the request, and it sees that the it don't have the website cached to it server. So what it will do, it will request forward this request to origin server. Okay, and this receiving request will cost it $1. Let's count the cost as well. $1 has been costed, and then the original file will be sent to CDN. And for this, a $2 will be cash. For example, a total of $3 is being charged by the origin server. Okay, and then this content is being served to the client, and the CDN will be cost how much? For example, sends it receives the query two times. So receiving charge will be 0.2 cents, and it sends the query two times, so it will be 0.4 4 to 8 0.8 cents for this. For this, a single maneuver of the data will cost 3.0 plus 0.8 $3.8, which is very costly in my terms of discussion. But this is the only first time cost, and if we add the upfront cost, this total will be cost 3.8 dollar plus 5.0. This is for the first visit. But whenever a single another client will visit, this will be queried none other than the first time. The data is already been cached in the CDN server itself, and it will be directly served. For every other user, the only charge that will be is a one send request and one receive request, that is only $0.3. And this is how CDN will actually saves the data. We have to actually find out the break even point. Then after how many requests the CDN, the cost of the CDN will be as equal to as directly charging the origin server, and how many, after how many times it will actually benefit it. So we have to find the break even point, but that's not the part of this video because that would be an economic video. uh, so never mind about the break even points right now. Once again, control A, delete. Yes. And let's continue with our topic. Finally, we have already discussed how it makes the resilience against attack. Okay. Never mind. Close this. Next is CDN performance. How does CDN improve load times? CDN will typically place server at the Internet Exchange Point (IXP), and these are the primary location where different internet provider are linked to each other in order to provide each other access to resources on the different network. In addition to Internet Exchange Point, a CDN will place server in data centers in location across the globe. Let me pause it so it won't disturb me. Yes. In addition to IXP, a CDN will place server in the data center in location across the globe in high traffic areas and strategic location to be able to move traffic as quickly as possible. So it will just repeating the same thing: distance reduction, software hardware optimization, and reduce data transfer. Okay, and now let's see. This cost calculation is done for the distance here. For example, the total transit time for the web page to load is about 3000 millisecond, which stands for 3 seconds. And if we use the CDN, you can definitely read the article. And just overviewing this, that the total transit time for this web page to load is 1100 millisecond. That's around 2 second reduction, around 2 second improvement. You can see here, and the latency for this website using the CDN service and without using the CDN service could be improved with 2 seconds, and 2 seconds is a huge time. And here we can see the latency in millisecond. The origin server, if directly serves the request, it takes around 3000 milliseconds, and if it is using the CDN service, the website can be served into merely 1.2 second. Okay, thus by reducing the total distance all necessary traffic needs to traverse each user, so the website is saving an amount of load time because user starts to leave the site very quickly as the wait time increases. Yes, you can also assume that, or you can also feel that if suppose you're using some application, for example in the old days of 2G and 3G, when you started opening Facebook and it is not loading an image, you will quickly close it and retry it, or retry another time, or switch to a different website altogether. For example, along with Facebook, we had Twitter. Yes, we have Twitter. So how does a CDN load content and what is caching? We have already discussed. This is the server, origin server serving all the requests. And this is the server distributed in every location and serving to their separate clients. Okay. After a TCP handshake has been made, the client machine makes an HTTP request to CDN server. If the content has not been cached yet, the CDN will first download the content from the origin by making an extra request between the origin server and the CDN edge server. We have already seen this. I have just told you by the example that what will happen if the content is not on the edge server or the CDN server. Okay. And yes, so I was talking about the code minification. Here I can see a few JavaScript code. So this is a function. Function is named say hi and takes a parameter called name. Actually, it doesn't matter if we write name here or we can simply write O here. So this is a function that says say hi, but with the name, which contains of 4 characters. So these characters can be reduced to a single character in this minification or single line of code. The code is actually doing the same thing, but we are reducing the number of line, reducing the number of characters, and even we are not using spaces. So just after, because this closing curly braces marks the end of the code, uh, we are just calling the code right after it. Even we are not using, we are not wasting even a single space. Okay. Now the code snippet has been reduced to 8 line to a single line. The overall file size has also been reduced. This means that it takes less time to transfer the file, which reduces the latency and helps to improve the load content faster. And finally, we have compression. We simply making zip files. For example, gzip is a common method of compression, and it will save around 50 to 70% of the initial file size. Okay. And hardware can also use improved speed. We have just seen the hard disk drive and the solid state drive, and it can open the files up to 30% faster. So the computer that I am actually teaching on has used a 54 RPM hard drive, and the booting from this computer actually takes millions of years. For example, if I start booting this computer up, I can go make a tea, and it's been 2 minutes and this computer has already started loading the circle and circle thing. So what I did is actually I installed a SSD myself, and after that, and I have also removed Windows and started using Arch Linux. And now the boot time is actually, my boot time is 10 to 15 seconds, or mostly the 20 seconds, and my computers gets ready in between. Okay, so the solid state drive is a form of persistent storage, a storage that does not clear itself after the removal of power, but they functions much more similarly to this kind of thumb drives, okay, or memory cards commonly found in devices like digital cameras, because there are no moving parts. So if a regular hard disk is spinning and the system is jolted, for example, the power got cut off, the HDD may skip, resulting in read-write errors and potential downtime. Another important SSD benefit is in accessing the fragmented files. The file fragmentation is a situation where parts of file are in different location across the disk, specifically when you partition the disk, resulting in slower access for HDD drives. Because a SSD can access non-continuous memory location efficiently, fragmentation is not a threat to performance. Okay, I hope you are guys getting it. We have on the performance section. Let's see the reliability section as quickly as possible. CDN benefit, reliability and redundancy. One of the important characteristic about a CDN is ability to keep the website content online. Okay. What is load balancing? We have seen the load balancing is distribution of load. It can be done using the software service, or it can be and special hardware can be utilized in order to actually do the load balancing. Okay. I think Nginx is a web server or a load balancer. I am just guessing. Uh, is Nginx a load balancer? Yes, Nginx, which is a software based load balancer, uh, which can distribute the incoming network traffic across multiple servers to enhance performance, reliability, and scalability, with various load balancing method, including round robin method and the least connection method. Okay, we will see that. We will see what actually these different algorithms do in a future separate video, because this time we are covering the CDN. And CDN also uses the load balancing to make changes quickly, efficiently when the availability of server resources fluctuate. So here we are seeing the diagram specifically of a load balancer. Uh, this can be a physical device, or it can be a device with a software, and the load balancer could be in the cloud. So every traffic has to pass with a load balancer, and this device or this guy decides whether the traffic should be served by the server 1, server 2, or server 3. And if three devices are asking for it, the first traffic will go to server 1, then it might go to server 3, then it for the server 3, depending on how this load balancer is configured. Actually, the configuration of load balancer is basically the algorithm or the weight of the traffic. For example, suppose we have three different servers with three different properties. And for example, the server 1 is the slowest of all, server 2 is the fastest of all, and server 3 is mediocre. And we have 5 requests. So if we can configure the load balancer to serve the two of these requests using the fastest server available, then remaining two with the second fastest, and with the last remaining single request with the slowest server available. So the not a single server gets overwhelmed. And if we don't use the load balancer, then all the requests will be served by the slowest server, and every user will experience some issues with the website. So this is how the actually load balancer works. And finally, we are discussing about the failover. The failover is a computer system that requires high when computer system requires high degree of reliability and near continuous availability. The failover is used to prevent traffic from being lost or when a server is available. We have seen the failover. So, for example, I just exemplify how when origin server requires maintenance, time to time maintenance, it can offload its content to a CDN because by increasing the time to live, and hen can be offline for a few hours or minutes, and the content is actually being served by the CDN. Finally, now that the traffic no longer able to pass through the intended network, it must step into entirely different network maintained by different organization. This process of negotiation and switching network may occur multiple times in a network request. And instances like this can add latency and may push the traffic into congested pathway, resulting in delay. A CDN of sufficient size will typically control its own network connection by placing server in internet exchange point and other strategic location, optimizing network schema, and allow CDN provider to optimize the route to reduce latency. And we have seen how the Anycast will distribute the load between multiple servers if the one server is feeling overwhelming, and the finish of the article has been come. Okay, and finally, the how the CDN reduce cost. Let's visit it and go with it as fast as possible. CDN can reduce the bandwidth cost. Okay, web hosting services charge for the data that is being transferred to and from to or from the origin server, and this is often called the bandwidth. But if the most of the website content cached within a CDN, far less data need to be transferred in and transferred out, and resulting in lower bandwidth cost. Okay, and yes, this is the thing that I was talking about. Bandwidth is not the actual bandwidth in the context. When people say bandwidth in context of web hosting, what they really mean is data transfer. Okay, and the actual data transfer is called throughput. This is the amount of data that goes to and from the web host. Bandwidth really means the maximum amount of data that can pass through a point on a link or a network over time. Therefore, web hosting does not result in bandwidth cost. But your service provider may charge with the bandwidth cost because to get a higher bandwidth, you have to use the higher quality of equipment, and then that equipment could be costly. So you can be being charged more. But actually, the this that would be the what to say upfront cost, the capital cost, and the variable cost would be the actual throughput of data that you actually utilize from this line. A certain amount of data per time, typically per month, is allotted by the hosting provider, and the provider will charge for either ingress, the data going in, or egress, the data going out fees, whichever is higher. Okay. When user visit a website, their browser will load content via internet, and if the content does not use the CDN, all the content will have to come from the origin server, which means every time the website loads, the HTTP request go to the origin server and content goes out from that server. The more this time happens, the more data is transferred, resulting in higher cost for the website operator. And most CDN charge for their service, we have already seen, but the savings on the monthly data transfer will typically outweigh the cost of using CDN. We have already seen that. and time to do some CDN metrics. We have round trip time, which in short stands for RTT. Let's see. It is the duration in milliseconds it takes for a network request to go from starting point to destination and back again to the starting point. The RTT, which stands for round trip time, we have just seen, is an important metric in determining the health of connection on a local network or on the larger internet. It is used by network administrator like us, me and you, to diagnose the speed and reliability of the network connection. Reducing the round trip time is the primary goal of CDN. It can be done using by reducing the distance and modifying the standard TLS SSL handshake. Okay, so how this round trip actually work? So let me annotate it. So you guys can now see here, this is a round trip map. Okay. Suppose New York says hi to the Singapore, and Singapore will send back a hello. So the every minute or millisecond cost between sending and hi. So this hi will be sent to this first hop. First it had to be go from here, then from here, then it will be received by the Singapore. And after receiving it, the Singapore will send hello to New York, and this has to be go to from here, and after that, after the sixth iteration, it will receive by here. So the every time, for example, for every hop, it takes 1 second. So how many seconds will it take? 1, 2, 3, 4, 5, 6. It will take 6 seconds to actually receive the data from the point A to point D. So the round trip time between the point A to D would be the 6 second. So there is different round trip time depending on the point. Suppose if we are discussing about the point A and point C, the round trip time would be 1 second, 2 second, 3 second, and 4 second. So from A to C will be 4 seconds. From A to D would be 6 second, and for A to B, let me write it here. A to B would be how many seconds? 2 seconds. This is how we calculate the round trip time. It is important to keep in mind that round trip time is an estimate, not a guarantee, because the pathway between two locations can change over time, or other factors such as network congestion can also come into play. Okay, let's quickly see the factors affecting RTT. The nature of the transmission medium. So the transmission medium may be wireless, it may be wired, and if even if this is wireless, there may be multiple types of wireless connection. For example, it can be Bluetooth connection, it can be Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, Wi-Fi 7 even. Okay. And if it is wired, it may be some sort of Ethernet connection, optical fiber connection. Even in the optical fiber connection or a Ethernet connection, there may be various distinction. For example, we have categories of cable connected to it. We have a single mode fiber, do a multi mode fiber in Wi-Fi fiber connection. So all these things matter, and the slowest between the link will actually bottleneck the whole network. Okay, next is local area network traffic. Suppose for a single router or single home, a single router actually uses to transfer the data internet connection from the ISP to the house. And if someone is watching a 4K stream, or someone watching a television on 4K using the same network, then every other person will see a slowdown in the network. And so the local area network will also increases the RTT round trip time. Next is server response time. It may be possible that this server is itself slow. So even if you use the highest quality connection available, the actually transmission would be slow. Next is node count and congestion. Okay, depending on the path that a connection takes across the internet, it may be routed or hop through different number of intermediate nodes. We have already seen the node count in which we used to get 6 seconds of delay using my metric. Okay, The greater the number of nodes the connection touches, the slower it will be. A node may also experience network congestion from other network traffic, which will slow down the connection even further and increase the RTT round trip time. Next is physical distance. Although a connection optimized by CDN can often reduce the number of hops required to reach a destination, there is no way of getting around the limitation imposed by the speed of light. The distance between a start and end point is limiting factor in the network connectivity that can also be reduced by moving content to closer to the requesting user. To overcome this, a CDN will cache content closer to the requesting user, thereby reducing round trip time. And can a CDN improve RTT? But by maintaining server inside the internet exchange point, by having preferred relationship with the internet service provider and other network carrier, a CDN is able to optimize network pathway location, resulting in reduced RTT, improved latency, and contain cache inside the CDN. Okay, got it. And do you guys have any queries regarding that? You can certainly read the article. Ask me in the comment. I will try my best to answer each and every comment possible. Now, time for discussing the time to live, TTL. So TTL refers to the amount of time or hops that a packet is sent to each set to exist inside a network before being discarded by a router. So that was the time to live used by the network packets. So the time to live is also used in other contexts, for example, CDN caching and DNS caching. When a packet of information is created, sent out across the internet, there is a risk that it will continue to pass from router to router indefinitely. To mitigate this possibility, packets are designed with an expiration date called time to live or hop limit. A packet's time to live can be useful in determining how long a packet has been in circulation and allows the sender to receive information about the packet's path through the internet. Each packet has a place where it stores a numerical value determining how longer it should continue to move through the network. Every time a router receives a packet, it subtracts one from the TTL count and then passes on to the next location in the network. If at any point the TTL count is equal to 0 after the subtraction, the router will discard the packet and send an ICMP back to the originating host. And till now, we have discussed the how do TTL actually work on a regular packet, not when it is being used in CDN to mention how much time the data should be cached. Okay, so keep that in mind. The commonly used network command ping and trace route both utilize time to live. When using the trace route command, a stream of packet will increasingly high sequential TTL are sent across the internet towards a destination. Because each step the connection is the last stop for one of the packet, each location will return an ICMP message to the sender after discarding the packet. The time it takes for ICMP message to return is used to determine how long it takes to each successive hop. And this is how we can get the RTT round trip time. Apart from tracing route packets across the internet, TTL is also used in context of caching information for a set amount of period of time. Instead of measuring a time in hops between router, each of us which can take a variable amount of time, some networking use cases operate in traditional fashion. For example, CDN like Cloudflare use a time to live to determine how long the cache content should be served from a CDN edge before a new copy will be fetched in order to update the database. By properly setting the amount of time between origin server pools, a CDN is able to serve updated content without requesting or continuously propagating back to origin. This optimization allows a CDN to efficiently serve content closer to a user while reducing the bandwidth required from the origin server. And this is how we finish the TTL. Finally, the most important thing, cache hit ratio. Cache hit ratio is the measurement of how many content requests a cache is able to fill successfully. compared to how many requests it receives. So the total request it receives will be serving as a denominator, and the actually request fulfilled will be served as the what to say numerator. And if we multiply it by 100, it will be in percentage that the itna for this far percent of the request is being served by the CDN. A CDN network provides a type of cache, and a high performing CDN will have a high cache hit ratio. The formula is mentioned here, and I have to switch to the light mode in order to make this formula visible to you. So this is the number of cache hits. Suppose the content served by this CDN, and this is the total content requested. For example, let's see an origin server again. It has web page 1, and we have web page 2, and this is a CDN server, and this has only cached the web page 1 till now, and this is our client 1, and this is our client 2. Client 1 asked for the web page 1, so it queried the CDN server, and the CDN server served the request. Okay, now one request has been completed, so we have the cache ratio of 100% till now. Okay, but if C2 asks for the page 2, web page 2, if it query it, the CDN don't have web page 2, so it will query the origin server. The web page 2 will be sent to here, and now this is also cached here, and after the caching, the request is served to web page 2. Because the CDN received the request, it leads to a total request in a number of 2, but it is not being able to serve with its own cache, so it has to query the origin server, hence it would be a miss. So out of these two requests, the request 1 and request 2, only one request is being served by it. So now the percentage become the 50%. 1 by 2 simply multiply by 100 is equal to 50%. And this is how the cache hit ratio is being calculated, which is 1 is to 2, or this is how the percentage can be calculated by multiplying it with 100. Simple basic maths. Uh, theme to target. Okay, now for example, if a CDN has 39 cache hit and 2 cache misses for a given time frame, the cache hit ratio is equal to 39 divided by 41, or 0.95. And if we simply multiply by 100, we have a cache hit ratio of 95%, or over 95%. And this cache hit ratio can be expressed as percentage. Okay, 95%. Okay, so what is cache hit? The cache hit occurs when a file is requested from a cache, and the cache is able to fulfill that request. For instance, if a user visits a web page that's supposed to display a picture of cat playing piano, the browser sends a request to web page CDN for this picture. And if the CDN has copy of this picture, then the request result in cache hit, and the picture is sent to the browser. And if the request is not available in the cache, then the CDN has to query the origin server, and this is considered a cache miss. A typical website that mostly made up of static content, it could easily have a high cache hit ratio of 95 to 99%. However, getting this metric right as high as possible is not the only goal of CDN. So it is a goal of CDN. So you have to keep that in mind. Additionally, a website with lots of dynamic content may have a lower cache hit ratio, because the dynamic content is cached on the client side, not on the CDN side. Okay, and cache hit ratio always mean a CDN is effective, because cache hit ratio is important, but not the last thing in the CDN performance. Other things, like for example the reduction in distance, for example the cost saving, also matters the use of CDN. So only this does not matter. For instance, where the content is served is also important. Ideally, a CDN will serve content from the CDN server closest to end user. If this does not occur, the CDN performance will not be optimal. Okay, caching is an important part of what CDN does, but the main purpose is to make web properties faster, more reliable in general. A variety of performance metric help measure how much a CDN can help to speed up a web app or website. Okay. And we have covered our CDN metrics, and this is how far I have covered in the previous video. And after that we have to see how caching works. Okay, and we have a video regarding that. You can watch the video. I'm not playing it because I'm afraid of YouTube, and we will see that. Actually, I have discussed the caching. Okay, so we will just do an overview regarding that. And the main next big thing in this CDN section is the CDN glossary. So we will see that, but just after a break. I require a 5-minute break. Okay, so I will be back again. So guys, don't get lost. I will be here as quick as possible. So let me pause the stream. So hooray, what I've already seen that it had been 55 minutes and 55 seconds already in this video, and I'm still not waiting, or I will still not stop till the CDN will be finished. So it will be a mega video regarding the CDN, all of the CDN that you can study about the best CDN provider, Cloudflare. Sorry. So we will first begin with the topic, what is caching? Okay. And in between breaks, all these ideas were popping in my mind regarding the thumbnail of this particular video. So we will implement it, and I will right after finishing the video I will make the thumbnail as well. So what is caching? How is a website being cached? So caching is the process of storing copies of the file in a temporary storage location so that can be accessed more quickly. A cache is any temporary storage location. Okay. So in the previous video that would not be able to make due to some power failure issues. In that video, I've already discussed about an extension called decentralize, because cache is any temporary location. It could be your computer. So decentralize, what it does, that it actually injects the locally stored content. So with this, if I have to explain this extension and what I think of this extension, how it actually works, let me open the editor, Control A, delete, and this time I'm going with a blue color pen. Okay, so this is the origin server known as OS. We have already know. This is the CDN provider, CDN, and this is your client device. Okay. So if a client has to visit something, it first queries the CDN server. If CDN server has the request is being directly served. If it does not possess that asset that the client is requesting, it will ask the origin server for the same. Then origin server will share the resource, and then the resource would be shared to the client. But right in between the equation, there comes this extension called decentralize. Instead of querying for the content delivery network repeatedly, what it do is it stores a copy of the data that is being regularly or repeatedly requested by the CDN in itself as offline. So the request going to the CDN is stopped, and the content is being locally injected by the extension itself. And this is decentralized. And we can see that for the CDN website particularly, there are 25 contents has been injected locally. Okay. So caching is the process of storing copies. We know, because there must be various thing common, because these are kind of static website. So there are various thing commons in all of these websites. So only the requested content or the only the new content will be fetched from the CDN server that stores this website, and most of the things are being reused by the extension that I have already installed. It will benefit in faster load times. Sometimes as the CDN can sometimes do the tracking, so it removes the tracking that also. Next, what does a browser cache do? Every time when user loads a web page, Their browser has to download a quite lot of data in order to display the web page. To shorten the page load time, browser cache most of the content appear on the web page, saving a copy of the web page content on device hard drive. This way, the next time the user loads the page, most of the content is already stored locally and page will load much more quickly. The browsers also store these files until their time to live expires or until the hard drive cache is full. A TTL is an indication of how long the content should be cached. Okay. Once a browser cache is cleared, every web page that it loads will have first time the user visited website. If the something loaded incorrectly for the first time, the end was cached. Clearing the cache also allowed it to load correctly. However, clearing one's browser cache can temporarily slow down the load time. CDN caching is quite like the browser caching, and I have already discussed with. We have discussed the CDN cache hit as well as cache mid, so I'm not going to be in detail. Where are the CDN caching server located? We have seen that it is located in a strategic location, particularly around data centers all across the globe. Okay, a location where CDN servers are present is also called data center. It is located around data center and it is itself a data center. And how long the cache data remain in CDN server. The TTL stored is in a part of response called the HTTP header. It specifies for how many second, minute or hour the content will be cached. When TTL expires, the cache removes the content. Some CDN will also purge files from the cache early if the content is requested and not requested for a while, or if the CDN customer manually purges certain content. What other kind of caching works? There are DNS caching and search engine caching. Okay. This for DNS, the server store the DNS lookup in their cache, so they don't have to query name servers and can instantly reply with the IP address of a domain. So in Windows, you have some command called IP flush, DNS flush, DNS flush command, flush command Windows 10 or 11. So it is used to manually flush your DNS cache on the Windows 10 computer. And for the same DNS flush command, Linux, there must be a DNS flush command in Linux too, and that is which is sudo resolve ctl resolve control flush caches. Okay, okay. And finally, the search engine may also cache web pages that frequently appear in the search result in order to answer user queries even if the website attempting is temporarily down or unable to respond. We have seen that with Google, with its all AI thing, it actually caches the website and the caches the particular lines of the website so it could be seen. Okay. And Cloudflare offers a CDN with 330 POP distributed internationally. Point of presence, I guess. The Cloudflare offers CDN caching service, while a paid CDN customer is able to customize how their content is cached. The network is anycast, meaning the same content can be delivered from any of these data centers. A user in London and a user in Sydney can both view the same content loaded from the CDN server only a few miles away from their own location. Okay. Next, static versus dynamic caching. Static content is a file that is stored in a server and it's same every time delivering to user. HTML files examples are the this kind of file. Static content is like a newspaper. Once the article or once the one issue of a newspaper is published, it features the same articles, photos, all for everyone who picks a copy, no matter what development transpires during the day. Dynamic content is a content that changes based on the factor of a specific user. For example, the time of visit, location of the device, etc. A dynamic web page will not look the same for everybody. and it can change as the user interact with it. Okay. For example, dynamic web page is something, for example, if you go to youtube.com and there you find a download a profile button with your names written on it. For every another person, there's a different name written on it. And there's different video each time for every person recommending by the YouTube. And so that is a dynamic web page. But if you visit my blog website, it would be a static web page for the because the blog remains the same. Okay, a modern news website is a good example of dynamic content. Unlike in newspaper, articles are updated throughout the day. Home page may feature different headlines based on the site visitor location or login status. It may change using a language, using a timeline of the day. Okay. Social media is also another dynamic website where the every person's feed looks totally different from a different user based on its liking, sharing, and commenting. So dynamic web pages are not stored as static HTML file. Instead, server-side scripts generate an HTML file in response to the event. And such user interaction or login send the HTML file to web browser. Because dynamic content is generated server-side, it is typically served from the origin server and not a cache. For a long time, dynamic content was considerable uncacheable, but the technologies allow website to serve dynamic content from the cache as well, significantly cutting down on latency while keeping the user experience interactive. Okay. Basically, storing and serving static content is quite easy. Okay. You just have to upload to a origin server. Then the copies of the origin server is made to a CDN server, and from that the request is being fulfilled. Dynamic content is generated by a script that changes the content on page. By running the script in CDN cache instead of a distant origin server, the dynamic content can be generated and delivered from a cache. This is essentially a revolutionary technology. Cloudflare workers, for example, serverless JavaScript function that run on the Cloudflare CDN can respond to a variety of events and input, including device type, type of time of day, user location, data from third-party API, and based on these parameters, dynamic content can be generated and served to client devices, or static content can be altered, cached, or purged from the cache. Because Cloudflare workers are nothing but JavaScript code, developer can use them to build a wide variety of features or entire application in addition to caching some dynamic content. Additionally, the Cloudflare workers can be deployed and can propagate the CDN location around the globe in the seconds. Okay. Next, difference between dynamic content caching and dynamic content compression. So basically, we are discussing the difference between caching and compression. Another approach to speeding up the dynamic website is to compress dynamic content. Okay, so these are entirely different things. This should not be a question as well. Okay, both are the ways of reducing the footprint of the content, or the footprint, not actually the walk of the content, the data itself. So we can either compress it, making it smaller in size, and we can make it as close as possible to the resource that is requesting it. And how does using edge side includes ESI speed up the dynamic web? Often, a large amount of content on dynamic web page remains consistent for all users, and only certain elements on the pages are dynamic. This means that much of the HTML code is duplicated in each dynamic copy of the page. To solve this inefficiency, a number of companies work together to develop edge side includes ESI. Let me copy it, paste it. A markup language that specifies where dynamic contents appear on a web page. ESI is used in some CDN but is not accepted by W3. I think World Wide Web Consortium. This stands for the organization that governs the web standard. Content with ESI tag is fetched from somewhere else, while rest of the web page content can be cached. If only some of the web page is generated dynamically, the rest is cached. The web page will load much more quickly than if the whole page needed to be generated for each use. ESI can be combined with Cloudflare Worker to make the process even more efficient. Okay, got it. And is there anything? Yes, we have cache control. Cache control is an HTTP header that detects browsing caching behavior. In a nutshell, when someone visits a website, their browser will save certain resources such as images, website data, and in a store called cache. When the user revisits the same website, the cache control sets the rule, determine whether the user will have those resources loaded from their local cache or whether the browser will have to send a request to the server for the fresh resource. In order to understand the cache control, a basic understanding of browser caching and HTTP header is required. Okay. So browser caching, we have discussed the browser caching. It is a web browser saves a website resource so it does not have to fetch them again and again. For example, a background image on the website might saved locally. For example, if I open the control shift and delete, and yes, we have the clear last browsing data and cookies. And here we can see the temporary cached files and pages, which is around 1 GB of file. Okay, so this is my browser cache of 1 GB. And browser will only store these resources for a specific period of time, which is defined by the time to live. If a user requests a cache resource after the time to live has expired, the browser will have to reach out to the server again and download a fresh copy of the resource. And how do browser and web server know the time to live for each resource? This is where the HTTP headers come into play. HTTP, which stands for Hypertext Transfer Protocol, outlines the syntax for communication on the World Wide Web. And this communication consists of requests from the client to server and response from server back to client. These HTTP requests and responses come from stamped with a series of key value pairs called headers. The header contain a lot more information about each communication. For example, a request header usually contain information on what resource is being requested, which browser the client is using, and which data format the client will accept. Okay. So the header contains important information. For example, even if you make a basic HTML file, for suppose example, we are making test.html. Okay, and if I just let me zoom it so guys can see it clearly. If I just write the basic boilerplate by using an abbreviation, you can see that every head of the HTML contains some important information. For example, what is the char set of the requesting next, what is the viewport, what will be where the content will be a scale and the size of a scale, what will be the title of document. These are on the head side because these are the important information for the system, not for us users. Okay, and information on what resources being requested, which browser client is using, and data formats that the client will accept. For example, the data format here is UTF-8. Okay. Response headers often include information on whether or not the request was successfully filled, the language and format of resources in the body of the response. Okay. The cache control header can appear in both HTTP request and HTTP response. Okay. Okay. So, what is in cache control header? The header consists of a key value pair which are separated by a colon. For cache control, the key or the part of the left of the colon is always the cache control. Okay. And the value is what find on the right of the colon. Can there be several comma separated values? Simply a CSV, comma separated values for cache control. Okay. These values are called directives and they dictate who can cache a resource and how long that resource can be cached and must be updated. So I think I should actually separate window. Okay. I go to network tab where I can find this style editor. No. Memory. Okay. Not in the memory. Storage, I guess. Okay. Cache storage. And there is no data present for the cache. Okay. I think I am in reader mode right now. That's why no data is being present here. So we will see that again. So if the cache control is private, the response with private directive can only be cached by client and never by an intermediary agent, such as a CDN or proxy. These are often resources containing private data such as website displaying users' personal information. Finally, the cache control public, which means that public directive means the resource can be stored by anyone. Cache control no store. A response with no store directive cannot be cached anywhere ever. Okay, this means that the every time a user requests this data, a request must be sent to the origin server for a fresh copy. This directive is typically reserved for the resources that contain extremely sensitive data such as bank account information. And finally, if there is no cache as directive, this means that the cache version of the request cannot be used without first checking if there is an updated version. This is typically done using e tag. The e tag is another HTTP header which contains a unique token to the version of the resource, and at time it was requested. The token is changed on the origin server whenever the resource is updated. Okay. So e tag basically is a kind of token. So when a user returns to a page with no cache resource, the client will always have to connect to that origin server, compare the e tag on the cache resource with one of the server, and if e tags are identical, the cache resource will be provided. If not, this means the resource has been updated, and the client will download a fresh copy to provide that to user. Then we have maxage, smaxage. So Max's directive dictates the time to live. In other words, many seconds a resource can be served, it been downloaded. For example, if max is 1800, that means for 1800 seconds, 30 minutes after the resource was first requested from the server, the user will serve a cache version of the resource on subsequent request. And finally, the cache control is smaxes. The smaxes is specifically for shared caches such as CDN. So if origin server wants to offload its data to a CDN, it will use the smaxish what directive for shared caches. It details how long the shared caches can be keep serving resource from the cache. This directive override the max age directive for the individual client. Okay. And does the cache control matter? Yes. Browser caching is a great way to preserve both resources and improve user experience on the internet. But without cache control, it would be very brittle. It will break. Every resource on every site would be bound by same caching rules, meaning the sensitive information would be cached the same way as the public information. And a frequently updated record would also be cached for the same amount of time as those rarely change. And hence the cache control adds the flexibility and make the browsing cache truly useful. So I have to copy a few things from this website because this website is full of such kind of resource. So first thing, I have to copy about the e tag. Okay. So to our readme file, we go into last and copy it about e tag. Okay. Then we have to copy every form of directive. Okay. Cache control directive, double hash, cache control directive. Okay. We have first thing here, cache control private. I'm not actually going to define it as the definition would be provided by GPT. And next is cache control no store. I think that most of these things are self-explanatory. Okay. Then we have cache control no cache, which does not caches at all. Next we have max age. And finally, we have S message, which overrides the message. Message for CDNs. Okay, good. Time to the move to the next one. Next one. And yes, now we are on this. We can see uh, cloudflare.com. This is the cache, and no data could be seen. A style sheet could not be loaded. Okay, but why so? These are the cookies stored, and can we see why we're not able to see anything? Session storage. Mm-hmm. Network tab, storage or performance. No, no, not in performance, memory. So actually, I don't really know how to use the developer console instead of just a few features. Let me try right clicking it. Nothing is happening. Okay, never mind. I'm sorry for wasting your time. Next, we have covered the caching, how the caching works, and now time for CDN glossary. And most of the things we already know because many of the things has are been shared from the DDoS attack series, and then we covered what we covered DNS series. So we know about Anycast. Let's see what the data center is. The data center is a facility housing many network computers that work together to process, store, and share data. Most major tech companies rely heavily upon data center as central component. Okay. Difference between a data center and point of presence. The data center and point of presence are sometimes used interchangeably. Distinctions are there. Generally speaking, a point of presence may refer to a company having a single server presence in a location, where data center may refer to a location that houses multiple servers. Instead of referring to multiple point of presence in one location, Cloudflare uses the term data center to indicate a location where many of the servers are maintained. Okay. The concept of point of presence rose to prominence during the court order breakup of Bell telephone system. In court decision, a point of presence referred to a location where the long distance carrier terminates services and shift connection onto a local network. Similarly, on the modern internet, a point of presence typically refers to where CDN have a physical presence in the location, often in the junctures between networks known as internet exchange point. Okay. A data center refers to a physical location in which computers are networked together in order to improve usability and reduce costs related to storage, bandwidth, and other networking components. The data center, such as Internet Exchange Point co-location facilities, allows different internet provider, CDN, and other infrastructure companies to connect with each other and share transit. Okay. So data center consideration are these. First is redundancy, then is efficiency, then is security, environmental controls, maintenance, and bandwidth. A data center is incomplete without the bandwidth necessary to handle all the requisite network traffic. The bandwidth considered as a central component. Environment, for example, the data center is such a sensitive thing, and because of the proper functioning of electronic hardware, the temperature and humidity need to be in control. Monitoring, for example, there must be monitoring or the maintenance staff must be present on the site. Okay. Next is security. The proper physical security in terms of electronic surveillance should be there. Efficiency, amount of electricity used in large data center rivals that of small town. So whenever possible, the data center attempt to cut down on cost by optimizing cooling process and using energy efficient hardware. Okay, okay. And for redundancy, in higher tier data center, multiple redundancy in power and backup servers are built into the infrastructure. So now we know what an data center is. Let's switch to next thing, origin server. We have discussed what an origin server is to process the incoming and responding to incoming internet requests from internet client. Okay. The concept of origin server is typically used in conjunction with the concept of edge server or caching server. We know what those things are. A difference between an origin server and CDN edge server. Okay. Basically, CDN are the copy of the origin server. The origin server is the original server where where a creator actually intends or put its content. Okay. So this is the origin server. This is the we have already seen. Can an origin server still be attacked by using a CDN? The short answer is yes, because the CDN does not render an origin server invincible, but when used properly, it can render an origin server invisible, acting as a shield for incoming requests. It can be used as, but hiding the real IP address of an origin server is an important part of setting up CDN. As such, the CDN provider should recommend that the IP address of the origin server be changed when implementing a CDN strategy in order to prevent the DDoS attack. Cloudflare CDN includes the comprehensive DDoS protection. Okay. Next, edge server. I think this has been explained in the origin server itself. It is a computer that exists at the logical extreme or the edge of the network. The edge server serves the connection between the separate network. A primary purpose of CDN edge server is to store content as close as possible, thereby reducing latency and improving page load time. And network connect across edges. Okay. So, in typical home or office or network with many devices connected, devices such as mobile phone or computer connect and disconnect to network through a hub and spoke network model. All of the devices exist within the same LAN, and each devices connect to a central router, though which are able to connect with each other. In order to connect a second network to the first network, some point of connection must be made, and here this thing is made. Okay, and by definition, an edge device is needed. If a computer inside a network A needs to connect to a computer, the connection must pass from network A to the second network, and then same paradigm is also works in complex context. Okay, such when a connection is made across the internet. Okay, and this is the edge server. Network A, network B, network C, etc. So network A, actually suppose this is my home computer. We have two or three smartphones and a computer here connected in network A. I am paying ISP and then ISP connects to the internet backbone with an edge server. Okay? And this is the IXP or the internet exchange point, I guess. The connection may traverse different internet service provider and internet backbone infrastructure hardware before reaching its target. Okay. Then a CDN provider will place server in many locations, but some of the most important are the connection point at the edge between different networks. These edge server will connect with multiple different networks and allow for traffic to pass quickly and efficiently between networks. Without a CDN, transit may take a slower or more convoluted route between a source and destination. In worst case scenario, the traffic will trombone a large distance when connecting to another device. We will see about this trombone effect in the next section or the next what to say. I actually not getting the word in the next web page about the trombone effect. Okay, by placing edge server is in a key location, a CDN is able to quickly deliver content. Okay, difference between edge server and origin server. We again got the difference. Is the web server that receives all the internet traffic when web property is not using a CDN. Okay, and CDN edge server store and cache content in strategic location in order to take the load of the main origin server by moving static assets like images, HTML, and JavaScript files to potentially other content to as close as possible to the requesting client machine, and edge server able to reduce the amount of time it takes for web resource to load. Whew, that was a great thing. Next, internet exchange point. And in this article, we are going to see the trombone effect. So specifically, let's talk about the trombone effect. Okay. Let me switch to reader mode as well. We have seen or we have discussed that the internet exchange point is a physical location when internet infrastructure companies such as ISP and CDN connects with each other. These locations exist on the edge of different network and allow network provider to share out transit outside their network. By having a presence inside of the IXP location, the companies are able to shorten their path to the transit coming from other participating network, thereby reducing latency, improving RTT round trip time, and potentially reducing cost. This article, I'm going to study it carefully, much more carefully than the previous one, because in this article we are going to discuss the trombone effect, and actually this article is the core part, how the internet works or how the internet exchange point also works. So the provider that one second, let me remove. Yes. So where I was? Yes. So we think that the internet is actually stored somewhere by the internet provider. At least that was my mentality until I started studying the network engineering, how actually the internet works. And this article duly defines how the internet actually works. So, for example, my service provider is Reliance Jio, and the actually internet is not something that is stored by the Reliance Jio. Actually, Jio is a part of internet channel. It connects to the main internet with me by accepting a certain fee. Okay. So, at its core, an internet exchange point is essentially one or more physical location containing network switches that route traffics between different member of network. And switches route different member of network. Yes, it can be. So, via various methods, these networks share the cost of maintaining the physical infrastructure and associated service, similar to how costs are accrued when shipping cargo through third party locations, such as via Panama Canal. When traffic is transferred across different networks, sometimes these networks charge money for the delivery. And to avoid these costs and other drawback associated with sender, their traffic across a third party network, member companies connect with each other via IXP Internet Exchange Point to cut down on cost and reduce latency. Internet Exchange Point are the large layer 2 LAN of OSI model, data link layer. That's why we are talking about the switches, uh, okay, that are built with one or many Ethernet switch connected together through one or more physical building. The IXP is no different in basic concept to a home network, with only real differences being the scale. The internet exchange point can range from the hundreds of megabits per second to terabits per second of exchange traffic. Independent of size, the primary goal is to make sure that many network routers are connected together cleanly, efficiently. In comparison, at home, someone would normally have one router and many computers. Okay. So, over the last 20 years, there has been a major expansion in network interconnection. Running parallel to the enormous expansion of the global internet, this expansion includes data center facilities being developed to house network equipment. Some of these data centers are attracted massive number of network, in no smaller part due to thriving internet exchange point that operates within them. So why are internet exchange point important? Without internet exchange point, traffic going from one network to another would potentially rely on intermediary network to carry the traffic from source to destination, and this is called the transit provider. In some situation, there's no problem in doing this. This is how a large portion of once again, internet traffic flows. It is a cost prohibitive to maintain direct connection to each and every ISP in the world. Okay. However, relying on a backbone ISP to carry the local traffic can be adverse to performance. Sometimes, due to backbone carrier sending data to another network in completely different completely different city, the situation can lead to what known as tromboning. Trombone is an actual music instrument which has a very long neck. If I show you the images from bone images. So this is how the trombone looks like. It has a very long neck. So what this article is defined to say, that if we don't use an internet exchange point and rely on the ISP itself for our local area network, what it will do? Suppose if we have to transfer some traffic right from this cone to this mouthpiece, and the distance between is very short, but if we rely on some other third parties, or third parties especially in the ISP, the traffic will have to go to a different city altogether, then it come back to the our source point. And what it will do, it will lead to delay, slowness, the higher bandwidth cost, the poor service, etc. And as you can see, the SF, the router in the SF and the router in the LA wants to share some traffic, but due to reliance in ISP, the traffic is completely shared over to New York, and then it will come to SF. And for the reverse, it will also do the same. And imagine the latency, because it all could be removed or trimmed down to a simple short distance. Okay. So a CDN with IXP presence has the advantage of optimizing the path through which the data flows when its network, cutting down on inefficient path. And for this, we are going to discuss a slight thing, because BGP is so large that even the 3 or 4 or 5 videos are actually far lesser to talk about how the BGP actually works. But it is a slight introduction. So BGP, the Internet Backbone Protocol. The network talk between each other using the BGP, which stands for Border Gateway Protocol. This protocol allows network to cleanly delineate between their internal requirements and their network edge configuration. All peering at Internet Exchange Point uses BGP. And how do providers share traffic across the different network? First is transit. The agreement between a customer and its upstream provider. A transit provides a customer with full connectivity to the rest of internet. Transit is a paid for service, and BGP protocol is used to allow customer IP address to announce toward the transit provider and onwards towards the rest of the global internet. And this is how the role of transit is played by ISP. For example, in my case, Reliance Jio. Next is peering, the arrangement behind how networks share IP address without an intermediary between them. At Internet Exchange Point, there is predominantly no cost associated with transferring data between member network. When a traffic is transferred for free from one network to next, the relationship is called settlement free peering. But because of the maintenance of the network itself, because network incurs cost, a large network with relatively equal market share are most likely to pair with another large network, but may charge smaller network for peering service. In single exchange, internet exchange point, a member company can have different arrangement with several member companies. In instances like this, and a company may configure their routing protocols to make sure that they optimize for reduced cost or latency using the BGP protocol. Finally, de-peering. De-peering is something far emotional. Suppose a party wants to earn some money on behalf of some other parties, or it see, or if that data trade share is not possible because it is receiving far more data than actually sending the useful amount of data, or simply in the article words, it is simply due to bad traffic ratios, the incoming and egress traffic. When a network simply decide to start charging the other party money, this process can be highly emotional. And a spawn network, what is a spawn network? The network that is left without any exchange point. Let's see spawn about the spawn network. What is spawn network? Just Let it load. Until now, we will continue with our article. This process can be highly emotional, and a spawn network may intentionally disrupt the traffic of other parties when the peering relationship has been terminated. And it should be loaded. No relevant. Okay. So I have to copy it and navigate to our trusty old friend, chat, Bing chat. This time Bing chat. Let me open it. Says it explain per network, and let me zoom it so you guys can also see what gibberish it is about to output. Sprun network. Yes, yes. Spurned network. Never mind. So we did not get any result regarding that. So what we will do, we will continue with our search where we were. Uh, how do internet exchange points use BGP? Across an internet exchange point local network, different providers are able to create one-to-one connection using the BGP protocol. This protocol was created to allow disparate network to announce their IP address to each other, plus IP address that they provided connectivity to downstream. Once two networks set up a BGP session, their respective routes are exchanged and traffic can flow directly between them. So, BGP is an external routing protocol or external gateway routing protocol, which requires manual configuration in order to share routes between two networks. So, two different ISP specifically shares each other routes, so connectivity can be maintained and data can be transferred for fees, probably. So, IXP and PNI interconnection. Two network may consider their traffic to be important enough that they want to move from shared infrastructure of an IXP onto a dedicated interconnection between the two networks. A PNI, private network interconnect, is simply a dark fiber connection, normally within a single data center or building that directly connects to a port on network A or port on network B. The BGP is nearly identical as a shared IXP peering setup. Okay. PNI stands for Private Network Interconnect. It's simply dark fiber connection. Okay, normally within a single data center. Okay, that connects port on network A with port on network B. Okay. And I do advise you guys to read this particular article on the Internet Exchange Point once by yourself. Now we are discussing about the reverse proxy. Okay. And the time has come. But before starting this, what I gonna do is to try to make you guys understand what is the proxy, and for this I am using the green coloring. So, in the very general sense, the proxy is basically a computer that is receiving traffic on someone's behalf. Okay, so first we have to put an internet in between. Internet, this is the actual internet, okay, from where the traffic has been originated. And then there is multiple clients. For example, let me draw some boxes for it. And one, two, three, there are three or four boxes. Okay, then there are four boxes here. Okay, and this side of boxes are known as client, CLIENT. Okay, and these boxes are represented as client 1, client 2, client 3 and client 4, and these boxes are represented as 1, 2, 3 and 4 as well, but as server. Okay, suppose when I don't want to be present in the internet but I still want to receive the data from the internet, I have an option. I can set up another computer which is called the client 5, okay, which will receive the data on the behalf of client 1, 2, 3 and 4 from the internet. So all these things or devices are connected with client 5, and all the transmission is done between internet and 5, and the data is actually after translating it will be sent to the client or the respective owner of the data or the respective requester of the data 1, 2, 3 and 4. And if this another client is between the group of client and the internet, this is called a proxy. What it simply does, it receives the data on behalf of some another computer. And for the same cause or for the same reason, if I do not want to expose all of my servers to the internet, we can set up a different server altogether, the server 5th. And if internet requests data from this server, for example, the server actual data is stored in server 1, but we use a different device, and this device first sends data to the 5th, and then 5th will serve the data to the internet. So only the IP address of the 5th or the IP address of this 5th will be visible to the internet, and actual data is stored somewhere else. And now the placement of this 5th device is placed between server and internet, then it was called a reverse proxy. Reverse proxy. And this is called simply proxy, and this will be called reverse proxy. And this is the basic difference. If it is between client and internet, then it is a proxy, and if it is between internet and server, then it is called reverse proxy. And now you can understand that between the actual internet where the data is requested and between origin server I can write it here, there is something called CDN in between, because we have studying it about more than 1.5 hour for the last 1.5 hour. So CDN sometimes also act as reverse proxy, and this is what we are going to see in the article. And this is the most straightforward diagrammatic representation that I could make. I hope you guys can understand it, and let's now continue with the article. The reverse proxy is a server that sits in the front of web server and forwards the client browser request to the web server. The reverse proxy are typically implemented to help to increase security and performance and reliability. In order to better understand how a reverse proxy works, the benefit it can provide, first define what a proxy server is. Proxy server, the normal forward proxy between internet and the between user device. There is a device called proxy server. Okay, okay. And why to use proxy server? These things to avoid state or intentional browsing restrictions. For example, this proxy server is allowed something to do in the internet, and this user device is not allowed to do. If this user request data, and for the user device A, on the behalf of user device A, this proxy server B will request, then the request will be fulfilled, and after that the data can be transferred or pushed into user device A, and it can bypass the browsing restriction. And during doing the same, it can also block access, it can also get access to the certain content. Alternatively, the proxies can also be used to block certain contents. It can use in for of blocking and in against of blocking. So it can be used to censor some content, and it can also be used to access the censored content depending on how you configure it. And it helps to protect the identity online because it hides your IP address. And the reverse proxy is just like the same proxy, but the proxy is set up between server and between internet. We have already seen that. And reverse proxy has a different kind of benefit. It helps to load balancing. It helps to protect from attacks. Uh, we have a different form of load balancing which called global server load balancing. In this form of load balancing, a website can be distributed on several servers around the globe, and the reverse proxy will send client to the server that is geographically closest to them. This decreases the distance that request and response need to be traveled and minimizing the load time. Uh, One second, I am receiving a call. So I'm pausing the stream for a little bit. So I will be back. Please be held because we are going through a topic that makes much more sense. Sorry for the disturbance altogether. So I actually got a call and actually got a call with a very good news that one brother of mine has got been placed in SBI as a clerk. I am very happy for that one. So that's all, and we will continue with our where we were. We were at caching. A reverse proxy can also cache content. We know because a CDN can also act as a reverse proxy. Okay, and finally we have SSL encryption. SSL encryption, the encrypting and decrypting communication for each client. So it raises the bar of the security by using a reverse proxy. It can be configured to decrypt all the incoming requests and encrypt all the outgoing response and freeing up the valuable resource on the origin server. And some companies build their own reverse proxy, but this requires intensive software and hardware engineering, as well as significant investment in physical hardware. One of the easiest and cost effective method or ways is to sign up for a CDN service. For example, the Cloudflare CDN that improves the performance and security features listed above, as well as various other features. So that's all about reverse proxy. And what we have next? GSLB, which stands for Global Server Load Balancing. Let me copy it, paste it here. Yes. So, Global Server Load Balancing or GSLB is the practice of distributing internet traffic with a large number of connected servers dispersed around the world. The benefit GSLB includes is increasing reliability, reduction in latency. Just like imagine a store. This is a very simple example. And load balancing is specifically a practice of distributing traffic among two or more servers. Some load balancing technique utilize a dumb load balancing strategy based on randomizing distribution of traffic. For example, a round robin DNS, a randomizing load DNS load balancing technique. So just still not able to figure out the difference between a normal working of a CDN and global server load balancing because as per the definition both are doing the same thing. And even before an origin server overloads and stop fulfilling requests, the high amount of traffic, the server can cause significant latency issues. The global server load balancing and distribute the traffic among different locations. Okay. And GSLB can reduce the travel time of the request and response between user and server. And if user in Los Angeles, they are using web service with Paris-based origin server, then both request and response will have to travel a very long distance, cutting into smaller segment called hops. This causes significant delay in load time. Okay. And one of the easiest and most cost-effective way to implement GSLB is through a CDN. Okay, so what the CDN does is the GSLB. Next, CDN, SSL or TLS or CDN security. Okay, let's go through it as quickly as possible. Like all network exposed to internet, CDN must guard against on-path attack, data breaches and attempt to overwhelm the network of targeted origin server using DDoS attack. A CDN can have multiple strategies for mitigating and one of these is SSL TLS encryption. The TLS is a protocol for encrypting data that is sent over the internet. The TLS grew out of SSL, the first widely adopted web encryption protocol in order to fix earlier protocol security flaws. The industry still uses the term interchangeably for the historical reason. Any website that is visiting started with HTTPS, for example, this website, rather than HTTP, which is using TLS SSL for communication between a browser and a server. Okay. So HTTP is not secured, but the S stands for SSL or security, you can say. The proper encryption practice are necessary or in order to prevent attacker from accessing important data, because the internet is designed in such a way that data transferred is across many locations. It is possible to intercept packet of important information as they move across the globe through the utilization of a cryptographic protocol. Only intended recipient is able to decode and read information, and intermediaries are prevented from decoding the information from transfer data. Okay. The TLS protocol is designed to provide three things: authentication, encryption, integrity. Authentication means verifying the validity of the identification. Encryption means obfuscate the information, and integrity means to detecting the forgery and tampering. Sorry, guys. So, in order to enable TLS, a site needs an SSL certificate and its corresponding key. These certificates are file containing information about the owner and the public half asymmetric key pair. Okay. This certificate authority digitally signs the certificate in order to verify the information in the certificate is correct. By trusting the certificate, you are trusting the certificate authority as it has done its due diligence. Okay. The operating system and browser have a list of certificate authority they implicitly trust. Implicitly means blindly, just trust it. So if a website presents a certificate that is signed by an untrusted certificate authority, the browser warns the visitor that something could be afoot. Certificates are a way that they are implemented independently rated based on a strength, protocol support, and other characteristics. Ratings can change over time as newer implementation become available. Okay. So if an origin server has lower grade SSL implementation, it will be typically graded poorly. Simple thing. A CDN has an added benefit of providing security to visitors of its property within its network using a CDN provided certificate. Because the visitor connect to the CDN, an older or less secure certificate in use between the origin server and CDN will not affect the client experience. Okay. Because here you can see the origin server has a C grade certificate, but a CDN has a A plus certificate. So the visitor visiting the website will see an A plus certificate, or the browser sees, which can here see, because this is a reading mode, so certification details is not visible here. For this website, I can see that the site information is secure and it is verified by let's encrypt. Okay. So realistically, this weaker server to edge security still represents a vulnerability and should be avoided, and especially with the ease which it's possible to upgrade the security by using the free origin encryption. Okay. The proper security is also important in the organic research. Encrypted web properties result in stronger ranking in Google search. An SSL TLS connection operates differently than a DLS IP connection. And once the initial stages of IP connection, TCP connection has been made, separate exchange occurs to set up secure connection. This article we will refer to the device requesting the secure connection as client and the device serving up the secure connection as server. This is the case with user loading a web page encrypted with SSL and TLS. Okay. The first TCP IP handshake is made in three steps. The client sends SYN packets, the server responds to that initial packet with SYN ACK packets, and finally the client returns the ACK packet. We know the three-way handshake already. So for a high level, there are three main components to a TLS handshake. The client and server negotiates the TLS version and type of cryptography cipher to be used in communication. The client and server takes a step to ensure mutually authentic communication. And third, a key is exchanged to be used in future encryption. So this is the what we see, and this is the additional things. So first is hello message exchange, and server hello certificate, server hello done is exchange. Then client key exchange and change cipher specification finished. And we have again changed cipher, and finally the connection get established. For illustrative purpose, this can be said that a TNS TCP handshake takes about 50 milliseconds. TLS handshake may take about 110 milliseconds. This is largely the result of time it takes for the data to be sent both ways between the client and server. The idea of round trip time, which is the amount of time it takes for the information from travel from one device to another and back again, can be used to quantify how expensive a connection is to create. If left unoptimized without the use of CDN, additional round trip time represents increase in latency and load time for end user. Luckily, there are optimizations that can be made to improve the total load time and SSL and how can SSL latency can be improved. Okay, so first we have to visit the light mode in order to get this diagram. Yes, the SSL optimization can reduce the RTT and improve load page time. Three ways to TLS connection can be optimized is first, TLS session resumption. A CDN can keep a connection alive between the origin server and CDN request for longer by resuming the same session for additional requests. Keeping the connection alive saves time spent renegotiating the connection. So this is the comparison between fresh connection and the connection resumption by opening the port for the server for much longer than the needed. Okay. Overall cost of a session resumption is 50% less than of a full TLS handshake, mainly because session resumption only cost one round trip, while a full TLS handshake requires two. Additionally, a session resumption does not require any large finite arithmetic. New sessions do. So the CPU cost for the client is almost negligible compared to that full TLS handshake. But low and slow attack usually opens the connection for a far more longer time. And while the normal DDoS attack actually overloads the connection with multiple requests at once. Next, for mobile users, the performance improvement by session resumption means a much more reactive and battery life surfing experience. Okay, next is false start. And I have written somewhere the TLS false start, star of the show. When a visitor is viewing the site for the first time, the session resumption mentioned will not be helpful because no already handshake had been completed. So the TLS false start allows the sender to send application data without a complete TLS handshake. Okay. The false start does not modify the TLS protocol. It only modifies the timing in which data is transferred. Once the client begins the key exchange, encryption can be assured and data transfer begins. This modification reduces the total number of round trip, cutting down the latency by 60 milliseconds. I just have to copy this. Okay. It one second, where it went. Okay, okay. Yes, it only modifies the timing in which data is transferred. Once the client begins the encryption can be so copy it. It it yes, and now we have zero round trip time resumption. Zero RTT allows for a session resumption without additional RTT added to the connection. For resume connection, use TLS 1.3 or zero RTT. One second. A connection speed is improved, leading to a faster and smoother web experience for the website who visits regularly. This speed boost is especially noticeable on mobile network. Zero round trip resumption (RTT) allows session resumption without RTT latency added to the connection. Okay, zero RTT is effective, but how it work? It doesn't. It is not mentioned. So we have a separate article regarding to zero RTT. We will see that, but some other time. It should be a part of some another topic. And the CDN protection, oh yes, we know how the CDN protects from the DDoS attack. So that's not going to cover the nth time in this today. And now finally CDN for WordPress. Okay. So WordPress has been controversial in part time because of some lawsuits going for and against it. So, but let's see what this article actually tells. CDN is a distributed network of server. We know what is it. CDN ensure that the WordPress hosted content is delivered quickly to site visitor. Improving experience, CDN increases reliability, CDN reduces bandwidth cost, and CDN integrate with a WordPress site. Okay, sorry guys. So forwarding network requests to and from two sites, a CDN can serve content on behalf of any website it hosts. The best CDN have a global presence which enables them to easily cache and serve content anywhere. Some WordPress hosts offer a built-in option for activating CDN service. Other CDN service required WordPress site owner to sign up separately. Okay. CDN protect WordPress site from DDoS attack. It does it by easily integrating high cache hit ratio, international presence, web application firewall integration, caching static and dynamic content, and CDN are not used for hosting. And yes, this is only thing that is worth reading. Site owner should optimize their website to load quickly since performance affect everything from SEO, which is search engine optimization, to conversion rate. Conversion rate means retention rate plus the actual the product that a website uh, wants to deliver it. For example, the conversion rate of my videos are very low. Simply the retention rate for my videos are very low. I don't know why, because I'm just keep studying, and if you guys interested, you can do keep a study with me. CDN boosts performance, but there's a ton of other optimizations possible for the WordPress site. Automatic platform optimization is a Cloudflare service that intelligently caches dynamic content. Okay, so both static and dynamic content are served from the Cloudflare global network. APO keeps the WordPress site fast. Even updates and slow plugins otherwise hinder their performance. Let me add this as well. APO. Yes. And this is how we completed the complete CDN along with its glossary in a single video. Let's see how much minute this video has been. This video has been around 2 hours and 6 minutes, which is such a great feat. And thank you for joining with me in this long journey. And thank you guys. Thank you.